In this video, I want you to learn how to figure out which substance got oxidized and which substance got reduced, as well as who played the role of oxidizing agent and who played the role of reducing agent. So we always start by assigning the oxidation numbers to all of our elements in the reaction. For cobalt and lead, over here, they are uncombined elements, their oxidation number would be 0. For chloride ion, it's -1. And we figure out from this combination of chloride being -1, double over the chloride, that the oxidation number of cobalt would be +2, and for lead it would be +2 as well. So now we know that the substance is oxidized when it loses electrons. And we can see that the cobalt over here is the substance that is losing electrons. Because of the loss of the electrons, the oxidation number of cobalt over here, 0, becomes +2. The oxidation number goes up. That's a very good sign of oxidation reaction. So cobalt was oxidized. When substance is reduced, it gains electrons, and we can see that lead, right here, probably gained electrons because its oxidation number +2 became 0. It obviously gained those 2 electrons that were lost by the cobalt. So the element that was reduced is lead +2. Now let's figure out who was oxidizing agent and who was reducing agent. Well, when you talk about being oxidizing agent, I want you to, in your mind, treat this expression as oxidizing helper. So who helped the reaction of oxidation to take place? To help anything to be oxidized, there should be a substance that is ready to accept those electrons that are lost during the oxidation. So oxidizing agent would be lead, because it is the substance that is accepting those electrons. The lead +2 is reduced, but it plays a role of oxidizing agent because it helps copper to be oxidized. It takes those electrons that copper released. And once again, understand the phrase reducing agent as reducing helper. Who was helping lead to be reduced? Lead got reduced, but something should have been giving those electrons that reduced the lead to lead +2 to lead 0. And the substance that gave off those electrons that helped to reduce lead was cobalt. Here's another example of redox reaction. Once again, let's assign the oxidation numbers, and that's already should be almost automatic. +2, +1 on hydrogen. So who was oxidized? Oxidized was zinc because it lost 2 electrons and the charge of zinc actually went up. So the substance that was oxidized is zinc. The substance that was reduced must have been hydrogen, because hydrogen had the oxidation number +1 and it went down, it got reduced, now the hydrogen is 0. So our substance that was reduced is hydrogen +1. Who played the role of oxidizing agent? Who accepted those electrons that were released in the process of oxidation? That was our hydrogen ions. And who was the reducing agent? The reducing agent was the reducing helper, the helper that was ready to give off those electrons that actually went to reduce the oxidizing number of the hydrogen, and that was zinc. And here is the last example that I want to give you of oxidoc reaction. Let's assign the oxidation numbers as always. So the oxygen, it would always be -2, hydrogen +1, uncombined chlorine 0, chloride ion -1, and manganese over here would have the oxidation number +2, and manganese over here would have oxidation number +4. So what was the substance that was oxidized? We are looking for substance whose oxidation number went up as it was losing electrons, and that would be chloride ions. They have oxidation number -1, and then we see it being 0, so the oxidation number went up. So our substance that was oxidized, Cl-1. And the substance that was reduced would be the substance whose oxidation number goes down as it is accepting electrons, and that obviously would be manganese because it has charge +4, and we see it here +2. So it accepted 2 electrons and went down. Manganese +4 is the substance that got reduced. So who was oxidizing agent? We pretty much switch what we have here. The oxidizing agent would be manganese +4 because it was accepting those electrons and was helping to oxidize chlorine ions, and Cl- were our reducing agents because it was helping by giving off the electrons.